Hey everybody, welcome back. Today we're going to go ahead and take a look at how to do calculations regarding empirical formulas. So in a previous lesson I talked about what empirical formulas are and the difference between empirical and molecular formulas. Here what we're going to do is just do a calculation just to show you how we take raw data and turn it into the empirical formula. Now if you remember what we said in the last video, we talked about the fact that empirical formulas show the whole number ratio, in this case the lowest whole number ratio of the elements in a particular compound. So in this case I have calcium, and I have oxygen, and I have hydrogen. Those are the three elements that I have in this particular chemical. So what I'm going to do is I need to figure out how many moles of calcium, how many moles of oxygen, and how many moles of hydrogen are in this. Remember, the ratio is the number of moles of calcium to the number of moles of oxygen to the number of moles of hydrogen. So remember, water is 2 moles of hydrogen and 2 moles of hydrogen and 1 mole of oxygen. So that would be how we would interpret those balance equations. So really what I'm looking for when I'm solving these things is I'm looking for the number of moles of each substance. So think about that whenever I bring up empirical formula problems to you, what we're referring to is how many moles. That's really the trick here. So what I want to do is turn this data into the number of moles of calcium, oxygen, and hydrogen. So the first thing to do is to get the percentages converted to grams. Okay, so to do that, we need to first understand what the percentages are. So we saw that in the past, and those percentages are based on masses. So if I have whatever particular mass of this compound, 54.05% of it is always going to be made up of calcium. 43.26% of it's always going to be made up of oxygen, and the remaining 2.7% is going to be made up of hydrogen. So I've got to figure out what is the full mass. You know, what is this the percentage mass of? Well, they don't really tell me. Well, because it's a percentage, it doesn't really matter. We can pick any number we want. We can have any mass of calcium, oxygen, and hydrogen of this compound. It'll always be that same percentage. So you can make up any number. You could say 250 grams of this compound, or you can say 1.250 grams of it. But I'm going to actually pick 100. Because if I pick 100 grams of this compound and I take 54.05% of it, the mass of the calcium is going to be 54.05 grams of calcium, right? Because that would be the percentage. And then I can do the same thing for the oxygen and for the hydrogen. Okay, so now that I've converted my percentages into masses, don't forget the goal is to find the moles of each of the substances that are in the compound. So I'm going to go ahead and do stoichiometry like we did before, or actually I should say mole conversions of grams of calcium to the moles of calcium. Okay, so what I did was I calculated all those moles, moles of calcium, moles of the oxygen, moles of the hydrogen. Just a couple points I want to point out to you, a couple points to point out. So if we take a look first at the molar masses of oxygen and hydrogen, I get a lot of questions on should I make these diatomic, right? They're supposed to be O2 and H2. Well, remember, we don't know what that ratio is right now, so that's only true. Oxygen is only O2 when it's by itself, so it's O2 by itself. Here it's not by itself, it's actually in a compound, so we're not going to make these diatomic. They're going to stay as individual elements. The other thing to do is to carry out way more significant figures than you would need. To be honest, significant figures are not that important here because we need whole numbers here. So we're really not even paying attention to significant figures because these are going to be whole numbers, like over here a 2 or a 1 or a 5 or a 6. So we don't really need to worry about that. So carry out more digits because when you do the division in a little bit, it's going to make things a little bit easier for you. So as of right now, I have calcium 1.349 to the oxygen 2.70 to the hydrogen, which is 2.67. So that's a weird formula. I really wouldn't want to write it that way, so I have to get it into those whole numbers. So what I want to do is, remember, moles tell us how much we have. So if I have 1.348 moles of calcium and this many moles of oxygen, I definitely have more moles of oxygen than I do the calcium. The question is, how much more? How much more oxygen do I have? Well, the way to figure that out is just to divide out the smaller one that you have. So if I divide 1.3485 by itself, that will give me an answer of 1 mole. So what I'm doing is I'm making this my reference point. I'm saying, okay, how many more how many more oxygens do I have than the calciums? So I just go ahead and divide this by the same number, and I can figure out how many more of the oxygens there are. In this case, when I do this division, I end up with 2.0 moles of oxygen. And this is why I want to carry out more digits, because these numbers get closer and closer to their whole numbers when we're finished. And as we saw for oxygen, there was more of that than the calcium. There's also more hydrogen than there is calcium. So I'm going to do that same division. So I'm using the calcium as my reference point, and I'm referring to the oxygen and the hydrogen to see how much more of each of those we have. Now when you do the calculation there, you get like 1.98. Now when you're this close to the whole number, you can go ahead and just roughly estimate it and say, you know what, it's close enough to 2 moles within significant figures that we can say that that is the formula. Okay? So what we can say at the very end here is we can now put this all together. What this means is that I have calcium, I don't like that color. There's calcium, there's one of them, 1 mole of calcium, to 2 moles of oxygen, to 2 moles of hydrogen. So it's a 2 to 1, 2 to 1 ratio between the calciums, the oxygens, and the hydrogens. Now, if you remember from ionic compounds, which is what this is calcium with a polyatomic ion, it's probably better to write it as this formula here. All right? Remember, with the hydroxide being in here, being doubled up. Technically, either one would be fine at this point right now, but hopefully recognize that that is an ionic compound. All right, so there you go. There's how you calculate your empirical formula. So just to recap really quick, what I did was I first recognized that I was looking for the number of moles. Remember, if I'm problem solving, what am I looking for? Ultimately here, I'm looking for the ratio of the moles. So I have to understand what chemical formulas tell me. So then I go out and I hunt for those parts. I look for the moles. So I took my percentages, assumed that I had 100 grams of substance, converted those to grams, used molar mass to find the moles, and then I figured out the ratio of the moles to get the overall formula. And again, this would be your empirical formula. All right, so there's another video lesson that I'm going to talk to you about the molecular formulas and how to calculate those. Thanks a lot.